In this video, we will talk about how to complete the squares for quadratic functions. So what is completing squares? Completing square is a very unique technique which been applied to a quadratic form and write the quadratic function as a completed square and plus minus a number. So here's an example. So the expression we have is x squared plus 6x, and we can rewrite it as x plus 3 squared minus 9, as we can see that x plus 3 squared is a perfect square and the minus 9. So this is the technique, is what we call the completing squares. So the question is, how would we know that we can write x squared plus 6x equal to x plus 3 squared minus 9? So we want to explain it geometrically. Well, the x squared we can regard it as the area of a square, and 6x will be regarded as an area of a rectangle, base times height, where base is 6, height is x. So base times height, you get a 6x. And therefore x squared plus 6x is going to be the total area of the region, which is the total area of the given square and the rectangle. So now what we want to do is we want to find a perfect square for that, because you can see once you combine these two regions together, it does not give me a perfect square. What we have here is a rectangle. So the strategy is to bisect the rectangle, which is 6 by x, that rectangle, into two halves. And well, what I mean by bisect is we have to cut it in half into identical parts. So we cut along the dashed line and then paste it on the top of a square. So this is the picture. So since you cut a half of that 6x, so what's remaining is 3x, and the other half is also 3x. Then once you place it on the top of the square, and you're going to see that the sides should flush left and the right, because the side is also x, identical to the side of the square. And if you take a look at this picture, and you realize that this is very close to a very big square with a side x plus 3. The only part that is missing is a top corner. And you recognize that what's missing, the shape of that corner, is exactly a 3 by 3 square. So what we have to do is patch it with a 3 by 3 square, and that way we will complete a big square. Well, however, once we add that 3 by 3 little square and we change the total area to balance that, and we have to subtract that 3 by 3 square. So therefore they offset each other, and we don't change the total area with the shape that we begin with. So once we patch that top corner into a big square, and this is we complete the big square right here. And so the new big square with the side x plus 3. So we finish the task. And now what we need to do is we need to write this whole process algebraically. Well, and you recognize that with the total area x squared plus 6, what we did is we patched the corner. The area of the corner is 3 squared, which is the side squared. And then we have to subtract the 3 squared to balance it, because we don't want to change the total area. And so we got x squared plus 6x plus 3 squared minus 3 squared. And so now you recognize the first 3 terms, which is the total area of that huge square. And so instead of writing it as the sum of 3 terms, and we can write it as the side squared, which is x plus 3 squared. And the remaining part is still minus the top corner, 3 squared. That does not change. So the last step is to simplify, because we can rewrite the 3 squared as 9. So the final answer is x plus 3 squared minus 9. And if you do remember, and this is exactly the same answer we have at the beginning. So now what we're going to do is we're going to take a look at another example. Let's say, well, what if we don't have 6x? We have some other number. Let's say 5x. And the process is going to be identical. The only difference is we just change the number from 6 to 5. And you recognize that how we get a 3 from the previous example, which is exactly half of 6, because we bisect the rectangle. So in this example, we do exactly the same thing, and we have that 5, and half of 5 is what? 5 halves. So therefore, we add 5 halves squared minus 5 halves squared. So you can see the only change is what? 3. And we change it to 5 over 2 squared. And now, as a previous example, we write the first 3 terms as a perfect square, which is going to be x plus 5 over 2 squared. And we still have minus 5 over 2 squared. And the last step, again, is to reduce it from 5 over 2 squared to 25 over 4, because 5 squared is 25, 2 squared is 4. So that's the final answer. Next example, what if we change from plus to minus? We have x squared minus 5x instead of plus 5x. And here's a little change we can make, and we can regard it as x squared plus a negative number, because x squared plus a negative number is the same as x squared minus the number. So we rewrite it as plus negative 5x. Now, and you can see that we still can apply the same method we used before, which is to take half of the coefficient of x. So this is what we get. And instead of 5 over 2 squared as what we have in example 2, now we have negative 5 over 2 squared minus negative 5 over 2 squared. Again, we rewrite the first 3 terms as a perfect square, which is a side squared. So now this time we have x plus negative 5 over 2 squared, then minus negative 5 over 2 squared. Last step is to reduce it, to simplify to the simple term possible. So plus negative 5 over 2 is the same as minus 5 over 2. So we rewrite the expression inside the parentheses as x minus 5 over 2. In the last part, again, we get a 25 over 4, because negative 5 squared is 25. So this is example 3. And the last example is x squared plus bx. So basically the question is, well, what if the coefficient of x is any number? And based on the first 3 examples, and you can see we can use exact same strategy to complete the square here. And you remember the whole process is to add the top corner and subtract the top corner. And how we get the top corner is to bisect the rectangle and with a side b. And so you half that b and you get a b over 2. So that's what we get, a plus b over 2 squared minus b over 2 squared. And if you remember the example 1 and 2, and the b was 6 and 5 respectively. And now the first 3 terms here is again the area of a big square, and so we can write it as the side squared. The side is x plus b over 2, and the remaining part is you square the b and you square the 2, so you get a b squared over 4. So that's the answer. Next example is, well, what do we have? 3 terms. We have x squared plus 5x minus 2. Actually, this example is no different from the example 2 we did. The only difference is we just have an extra constant. But if you remember in example 2, and to complete the square has nothing to do with a constant whatsoever. So basically, when we complete the square, you can ignore the constant part, so you just leave it behind. And then we just focus on the first 2 terms, which is x squared plus 5x, and we try to complete the square there. As what we did in example 2, we just plus 5 over 2 squared minus 5 over 2 squared to complete the square there. Then copy down that minus 2. So now the first 3 terms will give me the area of a big square. So I write it as a perfect square, which is in the form of the side squared. So the side is x plus 5 over 2 squared, which is identical to the example 2. Now what we need to do is we need to reduce the terms. And so now we get a minus 25 over 4. To combine the 2, and we must get the common denominator. And to get the common denominator, and common denominator will be 4. So therefore, I need to rewrite the 2 as 8 over 4. So now we need to combine the last two terms together with the same denominator. So we get a minus 25 minus 8 as a numerator. So overall, we get a minus 33 over 4. So that's the answer. This is the end of this video.